So let's do a problem with a vehicle. This is 13-15 in your book. I'm going to read the problem out to you. A 4,000-pound car traveling at 60 miles per hour decelerates at a constant rate and comes to a stop over a distance of 200 feet. Determine the minimum coefficient of friction between the pavement and the car's tires. Okay. So let's draw the car. Okay. And let's draw the forces. So this is 4,000 pounds acting downwards. Of course, there's a reaction. Right? I'm going to call that Fn. Right? The car is moving. I'm going to just assume the acceleration is this way, and then the inertial force is in the opposite direction, ma. So that's this way. So these are the forces we need to consider. And then because the car is moving in this direction, right, velocity is in that direction, here the friction is going to be in this direction, which is UK times F sub n. Okay? And again, this assumption of acceleration in that direction is just a general assumption. If my assumption is right, then I'll get a positive number. If my assumption is wrong, then I'll get a negative number for acceleration. Okay, so you don't have to worry. You can just initially, when you're drawing the free body diagram, you can assume. Of course, it has to be a guessed. It has to be a guessed assumption, but either way, the problem will correct for itself, meaning that if the acceleration is indeed in this direction, then the number for acceleration will come out positive. If it is in the opposite direction, which you will see actually is in this case, but I want to leave it like this so that you can see what happens when you make this assumption. Okay. All right, let's write the data down, which is initial velocity is 60 miles per hour. You know what that means? That means we got to convert that into feet per second. But for now, we'll just leave it. Final velocity is 0 because it's coming to an end. The distance it does over is 200 feet. And mu k is something we got to find. All right. So 60 miles per hour. So 60 miles per hour times, so miles, I'll write 1 mile, and then I know there's 5280 feet in a mile, and then hour, I'm going to write 1 hour at the top so it cancels out, 3600 seconds. So this all said and done, when you run the numbers, it comes to 88 feet per second. Okay. All right, so now we'll use the formula v squared minus u squared is 2as. So v squared is 0 squared minus this is 88 squared is 2 times a times s is 200 feet. So a is equal to you get negative 19.36 feet per second squared. So now look, we assume the acceleration to be in this direction and we got a negative number. So we can either leave these things the same way, right? These arrows facing these directions, meaning a is that way and ma is this way, and use a as negative 19.36, or we flip the a going to the left. I'm going to, let me do that in green. We flip the a this way and then the ma this way and change the sign here. Okay, so because I've already drawn this, I'm going to go with it. I'm going to keep these signs, these directions. I'm going to keep these directions and continue to use negative for acceleration. Okay. All right. So we have acceleration. Now we need to draw. Now we need to do the balance the forces out. Okay. So let's balance the in the x direction. In the y direction, there is nothing much. The 4,000 is balanced by Fn. So basically, Fn is 4,000. Okay. So in the x direction, I'm going to take right side as positive. So MA is to the left. So I'll say negative MA. Right? And then the mu k times Fn, the frictional force, is also going to the left. So I'm going to say negative mu k Fn. Anything else? That's it. Those are the only two. Those are the only two forces in the horizontal direction. Is equal to 0. Okay, minus mass is actually, we know 4,000 pounds is the weight of the car. Weight is force, so we need to convert that to mass. So that's why we do 4,000 over 32.2. Okay, times A is negative 19.36. Now, if, like I said, if this is my assumption, if acceleration is this way to the right and ma is going to the left, I can keep it like that in my equation and continue to use negative value for acceleration. That's fine. If I flip the directions here, then I flip the sign here. Okay, so either way you'll get the same answer. So if I flip the directions up there, this would be positive ma, meaning that would be going towards the right, and the acceleration would be positive. Okay, minus mu k, that's what we got to find out. Fn is 4,000. Okay, what do you get when you run the numbers? You get mu k is equal to 0.60.